Alright guys, so in this video here we're going to learn how to solve quadratic equations using the square root property, and then also using the complete and squared method. So quadratic equation in the general form is going to be ax squared plus bx plus c, where a is not equal to 0. So the first couple example here we look at quadratic functions or equation that just in this form only, and then the terms are 0, right? And then in 8.2 we're gonna have to solve quadratic formula where all three terms are there, and then sometimes it's factorable, not factorable. We use the quadratic formula to solve the ones that is not factorable. So 8.1 is the easier section just because we don't have the other two terms. So when we solve these type of equation, we just use the square root property. Okay. So example 1 here is asking us to solve for x. If we have x squared equal to 36, so in this case here we can think of that, okay, well, what number is squared to give us 36? Those two numbers are positive 6 or negative 6, right? If we think of this in terms of the graph, if we define our quadratic function as just x squared, then in terms of geometric interpretation, we're looking at what value of x such that the y value is 36. What are those two values? So the two values are 6 and negative 6. So that's what we just solved for there. In this case, x squared equals to negative 9. We don't have any x values. Why? Because, again, if we look at the graph of x squared, the y values are always positive, right? So there's no way we can find an x value, a real x value that give us a negative 9 down here, right? So there's none. So in this case here, x here is not a real number. So there's no real solution in this case. You can see from the graph there. However, in 7.8, we introduced the complex number system. So we can solve this using the complex number system. So to do that, we learned that, okay, well, we can take the square of both sides. If we do that, the square root of x squared and then the square root of negative 9 is going to be 3i, but then since the square root of x squared is absolute value of x, so that becomes x equal to positive 3i or negative 3i. In general, as far as the square root property go, if you have an x squared equal to some value k, then the two roots are either the positive root of the square root of k or the negative root of the square root of k. So if it's in this form, we can apply the square root property. Okay. By applying that to part B there, we want to get into the form of x squared equals something first. So we want to divide this first. Get rid of the constant. So that gives us 3 there. And then now it's in the form of x squared equal to k. K in this case is 3. So therefore that implies that x is equal to square root of 3, or x is equal to negative square root of 3. So there's two possible roots there, the principal root and the negative principal root. Here's some more variation of it. Let's do this one here. Okay, so to solve for x here, we want to add 5 both sides. That gives us 2x squared equal to 5. Then we'll divide by 2, so that gives us 5 half. Then we can square both sides or use the square root property. So use the square root property. So it says that if we have x squared equal to some constant, x is equal to the principal root of that, or x is equal to the negative principal root of that. Okay, so we can further simplify this into square root of 5 over square root of 2, and then times by square root of 2 to rationalize. So that gives us square root of 10 over 2. And then this one is going to be negative square root of 10 over 2. C here is not going to be a real number. It's going to be a complex number. So after we subtract the 9, we can divide the 4, so that gives us negative 9/4. And when we square root both sides, right, it's going to be a plus or minus 3i on the numerator and then 2 on the denominator. So that could be your answer there. Plus or minus 3i over 2. Okay. Exercise 4 here is a function notation question. It's asking for values of x for which the y value is 7. So we kind of solve for that. We say if the y value is 7, what x value lead to that? We have a quantity square equal to constant k7 here. So in this case, we can apply the square root property saying that will be x minus 2 equal to plus or minus square root 7. Add the 2 on the other side. So these are our two x value that use a y value at y value of 7. Here, question 5 is another quadratic equation, but for this one, it's not factorable, right? Or is it? Okay. So you have x squared plus 6x plus 9, x squared plus 6x plus 7 equals 0. I don't think this one's factorable. 1 and 7 doesn't make 6. So this one's not factorable. So what we can do here is, so not factorable. What we can do here is we can use the square root property. We can say that, is there any way we can take this equation and then we can make that where it's become something square equal to constant. If we factor the left hand side here, that's a perfect square. So now we can solve for this using this square property. So that becomes x plus 3 plus or minus root 2. Therefore, x equals to negative 3 plus or minus root 2, right? So using the complete square is when we take the quadratic equation and we isolate everything on one side is 0, and we force a perfect square from that side by adding or subtracting a constant. So going back to the same problem here, if we start with this here, it's not factorable. Okay. We can say, all right, I'm going to go ahead and force a perfect square on the left-hand side. First, I need to subtract the negative 7, subtract the 7 on the other side. And I'm going to go ahead and add both sides by the same number. Okay. So the trick is we divide the 6 by 2, the middle terms, and then we square that, and we do the same thing over here as well. Okay, so if we do this on the left hand side, we get a 9 for the constant. So that by adding both sides, this left hand side is a perfect square. And then that gives us the same answer there. So it comes from the fact that to force perfect square, the formula is the last term is half of the middle term and the square of that. Okay. And then that's what we did there in part A. Let's do part B. Okay. So if I want to solve this using complete square, first I bring the constant on the other side. Okay. And I'm going to add same number to both sides. And the number I'm looking for is half of the middle terms and then square that. Okay. So half of the middle terms coefficient and then square that. So that gives us what on the left hand side here we get x squared minus 10x. Negative 5 squared is 25. And then on the right hand side, negative 18 plus 25. Left hand side is perfect square. Right hand side is 7. So therefore x minus 5 equal to plus minus root 7. Therefore x equal to 5 plus minus root 7. So this is using complete square. All right. For a problem that has a coefficient larger than 1, we want to make sure the leading coefficient is 1 by dividing by that coefficient. And then we can proceed solving for x.